let's start. So last time we studied a few ways of counting, and if you recall, last time we mentioned that
multiplication principle.
counting can be used. Counting can be used for simple sample spaces, which means when you say simple sample space, it means a space that is finite. It does not have infinite elements, it is finite, and each element or each outcome in that sample space is equally likely, right? So it has two qualities. So we learned before last time actually that for simple sample spaces you can use counting to compute sizes of sets. And last time we looked at a trick used for counting, and that trick was the multiplication principle. And we learned that the multiplication principle was well, not the multiplication principle, but we learned another term, permutations, and permutations were ordered arrangements of distinct objects. The objects have to be different. And we learned that permutations were really, you count permutations based on the multiplication principle. So it's just a multiplication principle in disguise. And so for example, if you had three objects A, B, and C, you could, and now they're distinct, they're different, so you could arrange them in this way. That's one permutation. Or you could arrange them in this way, or you could arrange them in this way, or you could arrange them in this way. And you have 6 ways of arranging 3 objects. And these are the 6 permutations. And we also looked at the formula for permutations, that if you have to choose k objects from among n objects, you can do this in n factorial over n minus k factorial ways. Today we're gonna discuss a related concept called combination. And in a combination, a combination is an unordered arrangement. Unordered arrangement of, once again, distinct objects. The objects have to be different. So that these 6 permutations, let me copy them. So that these 6 permutations correspond to just one combination. Could you mute your mics? Could everyone mute their mics? just one combination. Could everyone mute their mic? Okay. 6 permutations correspond to just one combination, and now the formula for combinations is I want to give you a shortcut. You denote combinations using this formula. The number of combinations of k objects chosen from n objects when the k objects are unordered. This formula is just the number of permutations, the ordered ones, divided by k factorial. Why is that? Can anyone explain how I came up with this formula?
सर कॉम्बिनेशन का फॉर्मूला होता है n फैक्टोरियल ओवर k फैक्टोरियल इंटू n माइनस k फैक्टोरियल। तो
Okay.
k जब उधर जाके मल्टीप्लाई हो जाएगा और k फैक्टोरियल से कट हो जाएगा तो वो परम्यूटेशन ही बन जाएगा।
Okay, but based on what I've written above, for example, in this case, you had 3 objects.
Because a combination does not depend upon order.
Yes, that is true. But so over here you had 3 objects, and those 3 objects had how many permutations?
6
And that 6 was computed based on the multiplication rule or multiplication principle, isn't it?
Yes sir.
6 permutations. And this 3 into 2 into 1 is actually 3 factorial, right?
Yes, sir.
Now, let me ask a related question. If you had k objects, in how many ways could you have arranged those k objects when order matters?
K factorial.
So
K factorial,
the first
simple.
object could have been chosen from k objects. The second one could have been chosen from k minus 1 objects. The third could have been chosen from k minus 2 objects, all the way up to the last object, which would have been the only remaining object. So you choose it from only one, and that's k factorial, right?
Yes, sir.
And for the 3 objects example, we said that all of these permutations, since they contain the same 3 objects, they correspond to one combination, right? Right? We said it's just one combination because the objects are the same and we don't care about order. Similarly, for k objects, these k factorial different arrangements for us are the same one combination. Is that, do you understand that?
Sir, repeat kar
When we say combination, all we consider is that something contained A, B, and C in any order. It doesn't matter. So if you are counting the ordered arrangements, which you call permutations, those are 6. But if you're counting combinations, well, it's all of these are the same combination, because in a combination, order doesn't matter. For us, it's the same. It's just one combination. Let me change the example a little bit. Okay. Let's say you had 4 objects, A, B, C, D. And if I ask you, in how many ways can you pick 3 objects out of these 4? Out of these 4. Can anyone answer? And let me specify, in how many ways can you pick 3? So that order matters. Okay. If you change the order, for me, that's a new arrangement. Can anyone answer?
Sir, 24.
E की पावर में 4 आ जाएगा, फिर सबस्क्रिप्ट में 3 आ जाएगा हमारे पास.
Can you explain again?
यानी जैसे हमारे पास P और N के हमने पढ़े हैं ना पीछे डिनोट के लिहाज से, तो P N K में N की जगह पे 4 आ जाएगा और K की जगह पे 3 आ जाएगा, यानी हमने 4 में से 3 सेलेक्ट करने हैं.
Right. Perfect.
24 आ जाएगा सर.
So that will be 4 factorial over 4 minus 3 factorial, which is 1 factorial. So you'll just get 4 factorial, which is 24.
Yes, sir.
Okay. Okay, let's have a look at those arrangements, these 24 arrangements. One of them could be this, A, B, C, and all of the permutations of A, B, C. How many were they?
6.
6. Okay, 6 permutations of A, B, C. Another group of 3 could be A, B, and D. And you could order them in how many ways? 6. 3 factorial. Another one could be A, C, and D. And you could arrange that in 6 ways. Another one could be B, C, and D. And you could arrange that in 6 ways. Can there be any other combination of 3 objects? Or permutation? I've covered ABC, ABD, ACD, BCD. All are covered, right?
Sir, BAD.
It's done. Look at the second group. Look at the second group. BAD is done, right?
सर इसमें ये ऑर्डर मैटर्स वाली समझ नहीं आई सर. ऑर्डर तो इसमें चेंज हो रहा है.
Yes, so if the order is changing and I'm counting it as a different arrangement, it means that when you change order, I count it as different, it means order is mattering.
सर BAD की बात हुई तो आपने कहा था सेकंड में वो कवर हो गया. सेकंड में कैसे कवर हो गया? वो तो ABD है.
What are these different arrangements over here, these 6 arrangements?
सर जैसे हमने ABC की बात की थी तो हमने वहाँ पे 6 अरेंजमेंट्स लिखी थी, तो वहाँ पे हमारे पास अब फर्स्ट प्लेस चूज करने के लिए हमारे पास 3 अरेंजमेंट्स थी. हमने A को चूज कर लिया, उसके बाद हमारे पास 2 अरेंजमेंट्स थी, तो हमने पहले वाला तो फिक्स कर लिया ना. आगे हमें 2 मतलब हमारे पास आगे 2 और चेंजेस हैं हमारे पास.
Okay.
तो ये तो हमने फिक्स कर लिया, तो BAD और ABD में फर्क नहीं होगा.
No, we didn't fix A. So these are 3 objects that I've given you. Can you rearrange them? Rearrange. One is this arrangement, ABD. Give me the second one. Quickly, give me another arrangement.
BAD.
जिन्होंने सवाल पूछा था, the one that asked the question.
सर मुझे तो समझ नहीं आ रही.
Okay, just forget about the previous question. Just answer this question. I have given you three objects, A, B, and D. Can you arrange them
जी
in different ways?
ए बी डी हो सकते हैं सर, बी पहले आ जाए, डी पहले आ जाए।
No, give me an arrangement. Tell me what to write.
बी डी ए या बी ए डी।
Okay, B, A, D. Any other arrangement?
सर यहाँ पे डी भी पहले आ सकता है।
Just tell me what to write. D,
डी डी बी ए,
D, B, A, and
डी ए बी भी हो सकता है,
D, A, B, and any others?
डी ए भी हो सकता है।
B, D, A, any else?
उसके अलावा ए डी बी भी हो सकता है।
A, D, B, any other arrangement?
नहीं सर, यही बनते हैं।
How many are they?
6।
6. And I'm just saying that the arrangement of A, B,
ठीक
and
है,
D,
समझ गया।
right? Yeah. All possible arrangements of A, B, and D are in this group. And we know that those arrangements will be 6 because of the multiplication rule. 3 into 2 into 1. 3 factorial.
सर बोलिए 4 वाली सर रिपीट हो गई है।
Sorry?
Sir, BAD is repeated in this.
सेकंड और फोर्थ वाली।
Yeah, so what's the error here then? What should have I done? And it's not my
यहाँ पे
fault.
बी डी ए था।
It's not
BD
my
miss
fault.
हुआ।
It's the student's fault. I wrote what he was telling me to.
बी डी आना चाहिए।
What should I write for the 5th place?
सर
बी डी
BDA. All right. Or maybe he said BDA and I wrote BAD. I don't know. Maybe it's my fault. BDA. Anyways, and now I'm going to introduce the concept of combination then, which I've already done, but let's do it once more. This whole group of 6 arrangements of A, B, and C, when order does not matter, then all I'm looking at is, oh, it contains the same letters, it contains the same objects, but they're arranged in different orders. For me, it's a combination of A, B, C. But these 6 permutations, they are not a combination of A, B, C. They are a combination of A, B, and D. For me, it's a different combination. For me, all 6 orderings of A, C, and D, when order does not matter, is just one combination of A, C, and D. Similarly, one combination. So how many combinations did I get? How many?
सर
Wait, let me.
4 combinations.
फोर कॉम्बिनेशन।
Okay, wait. So from 4 objects, if I pick 3 objects and I do not count the different orderings, then I get, according to you guys, I get 4 combinations because we just counted 4 combinations here. And look at the formula that I had. The formula that I had is combinations equals permutations divided by k factorial. Let's see. Permutations were 24. And I divide by k factorial. Now what is k factorial? 3 factorial,
3 factorial.
which is 6. And you get 4. My question is, why did I divide by 3 factorial? The answer is here, what we did over here on the right.
सर क्योंकि हमें 3 का सेट चाहिए, 3 के सेट कितने बन सकेंगे?
Yes, all the arrangements of 3 objects are counted as 1. In permutations, you counted each arrangement of these 3 as a different permutation. But
सर जी
now,
उर्दू में समझा दें।
but now all of the arrangements,
सर आप अपनी पिछली लैंग्वेज की तरफ आ रहे हैं, हम आगे हो गए हैं।
सर उर्दू में समझा दें।
what's your name?
सर
what's your name?
Zaim sir.
Zaim. Zaim, are you having problems with the language?
नहीं सर इतना क्लियर नहीं हो रहा इंग्लिश में इसलिए कह रहे
Maybe
सर मुझे भी प्रॉब्लम है.
maybe English is not to blame. Maybe it's your instructor.
नो सर इंग्लिश का कसूर है इंस्ट्रक्टर का
Well, we can try other languages, but what will become of Abdul Haq?
सर वो नहीं है क्लास में
सर वो ट्रांसलेटर कर लूँ बैल में.
Sorry?
अब्दुल हक.
No problem, sir. You can just give lecture in Urdu for them. I'll recover and I'll see.
सर वो ट्रांसलेटर ऑन मोबाइल में से कर सकता है या कैप्शन ऑन कर सकता है.
If they have problems, sir.
No.
Just,
First of all, Zaim, he was in the class. So be careful when you talk about other people. He was in the class and you said no, he's not in the class. Number
सर
one.
पहले नहीं था अभी आया मैंने देखा था फिर.
All right. Number two, in PUCIT, we receive students from outside Pakistan as well. And therefore, the ground reality is that the language of science is English. Whether we like it or we don't like it, the language of science right now is English. And we must be able to communicate in that language.
सर हम इंग्लिश भी उर्दू में समझते हैं सर.
I know, but so then what's the problem? I can continue the lecture in English and you can understand it in Urdu, right? Look, bear with me for a few lectures. Maybe you'll get used to this. All right? I can understand
सर
that.
आप इंग्लिश उर्दू जरा मिक्स लेके चलें तो फिर काम ठीक है सर.
Sir, you can create a new language.
Very nice. We can, if there are any problems, that's why I have office hours. When I have office hours, we can communicate in Urdu or whatever language you want, but officially the lectures are going to be conducted in English. All right? Okay, let's continue. And it's not as if you don't understand any of this. I mean, you understand the language. If the problem might not be with the language, the problem might be with how I'm explaining. So let's continue. Okay. Okay. Okay, so we had 24 different orderings. We had 24 different arrangements of these three letters. And every group of 3 factorial orderings was counted as one combination. Every group of 3 factorial orderings was counted as one combination. Therefore, you just divide by 3 factorial and you'll get the number of combinations, right? You divide the permutations by the number of orderings, because these 3 factorial orderings, for you, they're counted as one combination. So just divide 24 by 6 and you get your combinations.
सर हमने इनका ही क्यों ग्रुप बनाया है? 2 का क्यों नहीं बनाया?
Oh, because the question was, so the question is, why did we pick 3 objects? Why not 2? Because the question asked you to pick 3. Let's change the question.
सर अगर यहाँ पे लिखा था कि you pick 4 तो हमने 4 के बनाना था ना फिर.
Okay, let's do that one as well. How many ways can you pick? First, let's do 2 objects. How many ways can you pick two objects out of these four when order matters and when order does not matter? All right. So what's the answer going to be? Anyone?
12, sir.
So there are two questions, right? When order matters and when order does not matter. So which question are you answering?
पहले परमुटेशन निकाल लेंगे फिर उसको परमुटेशन को कॉम्बिनेशन से ना 2 पे डिवाइड कर लेंगे 2 फैक्टोरियल पे.
So from four objects, I need to pick two objects, and
परम्यूटेशन सर 12 आएगी
yes,
और कॉम्बिनेशन 6 आएगी.
over and 4 minus 2 is 2 factorial. So this is going to be 12, and combinations are going to be just this 12 divided by 2 factorial, which is 6. Should we verify? Let's try. One group would be AB. I only have to pick two objects, right? And then I can rearrange it and get a new ordering. Okay. Another group would be AC and then CA. Another group would be AD and DA and so on. Or let's complete them. One grouping is AD and then there is DA. What else? Can I do BC and then CB, and then I can pick B and D, and then DB, then C, D and DC. How many are these? I hope they're not more than 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Are there any other arrangements of two objects picked from these four?
No, sir.
Right. And this group is just a permutation of AB, right? AB and BA. These are two permutations, two different orderings of AC. These are two different orderings of A and D. These are two different orderings of B and C, B and D, C and D. And for each of them, if order does not matter, it's just one combination. Because this combination is of A and B. This combination is also from A and B. This combination is from A and C. This combination is also from A and C. So it's the same combination, right? And so you have 12 permutations when order matters, but you only have 12 divided by 2 because each group of 2 is counted as one combination. So you have 12 divided by 2 equals 6 combinations. Is the idea any clearer?
Yes, sir, now it's clear.
Okay.
Yes, sir, it's clear.
Okay. Do you guys want to? So I leave the other one. I leave the other question for you guys. When you have to pick 4 objects. Okay. Let's leave that as homework. When you have to pick 4 objects out of 4. Very simple.
सर हमें ये कैसे पता लगेगा कि परम्यूटेशन वाला फॉर्मूला किस क्वेश्चन पे लगाना है और कॉम्बिनेशन वाला?
Exactly. Very good question. That's a very good question. You always have to consider is, do I have to count the different order as a different group? Right? If someone says to you, so when A comes first, it's a different order. B comes first, that's a different order, right? Whenever order matters, then you call it a permutation. And then you just use the multiplication. You don't even have to call it a permutation. You can just use the multiplication rule. Really, everything that is behind these two formulas is really, it's the multiplication rule.
सर अगर हम इसी क्वेश्चन के अंदर ये करें कि ए पहले आए, तो हमने दो सेलेक्ट करने हैं इस चार में से जिनमें ए पहले आए.
So you're saying you want to change the question and say that A has to be fixed at the first place.
जी sir.
Okay, so let's make a new question. So you're saying we fix A. Fix A at the first position. Now what's your question? What's your question now?
सर क्वेश्चन ये था कि जैसे ये ABCD लिखा हुआ है, इसके अंदर से हमने तीन वर्ड्स का हमने बनाना है कॉम्बिनेशन जिसमें A पहले आए.
How many ways can you pick? Okay, what objects do you have? A, B, C, D?
Yes, sir.
Okay, that's the first thing. The second thing is you fix A at the first position. And in how many ways can you pick the remaining two, right?
Yes, sir.
Because you have to pick 3 total. And in your question, does order matter or does order not matter? Like for example, if I pick A, B, C, and then I pick A, C, B, for you, is it different or is it the same?
सर इसी चीज की कंफ्यूजन है कि ऑर्डर मैटर्स में और ऑर्डर नॉट मैटर्स में क्या फर्क आ रहा है, क्या होता है क्या उसमें?
Yeah, let's remove the confusion then. So if I ask you A, B, and C, if every time B appears at the second position, you win 100 rupees. Now, will these two orderings matter for you or not?
सर मैटर तो करेगी, लेकिन पहले वाले ऑर्डर में मैं 100 रुपया जीतूंगा.
Okay, so you win 100 rupees, and over in this ordering you win 0 rupees. So does the order matter then? Yes or no?
Yes, sir. Matter, sir.
So that's all I'm saying. In those situations where the ordering matters, you use permutations. And in those situations where the ordering doesn't matter, and you just want to count how many combinations are there, without regard to how they are arranged, then you just.
So, लेकिन ये कैसे पता लगेगा कि ऑर्डर मैटर कर रहा है कि नहीं कर रहा?
ये सवाल से. Let's say you're playing a game. Let's say.
हर बारी बताएगा तो नहीं.
Let's say we play a game where I have 3 objects or 3 balls in a box, A, B, C, and in that game you reach in the box, you pick one object, then you pick the second object, and then you pick the third object, and you win 100 rupees if you get B over here. If. Now in such a game you will only win 100 rupees if B comes at the second place. So if you get something like this, you will win 100 rupees, but if you get something like this, you will not win 100 rupees. When all of these combinations, when all of these are just the combination of A, B, and C, but there's only one ordering, or maybe there are 2 orderings in which you win 100 rupees. So if I ask you what is the probability of winning 100 rupees, how will you answer this? And I'm not asking you to answer it right now, but I'm just asking you to appreciate that if I wanted to compute the probability of winning 100 rupees in this game, which is a game of chance, it's a
1/6.
random experiment. So if you wanted to compute the probability, it might have involved size of event divided by size of sample space, and you might have counted the number of ways, and you might have counted the set sample space, right? And in this counting, sometimes the order will matter, sometimes the order will not matter, depending on which game you're playing. Okay?
वो समझ नहीं आई परम्यूटेशन कब लगाना है और कॉम्बिनेशन कब लगाना है.
Okay, so you can read the lecture PDFs as well. There are some, and you can attempt some questions as well. And if you're still confused, send me an email and we can discuss more. Right? But is everyone confused?
No, sir.
No, sir.
Okay, then I can try and move on. So there was this question. Yeah.
ये जो आपने एक्सपेरिमेंट लिखा ना ABC, ये जो लास्ट लिखा है इसमें उसने कहा है कि अगर B जो है सेकंड पे होगा तो वो 100 रुपया जीतेगा.
If B comes at the second place, you will win 100. Okay.
तो इसमें अपने एक्सपेरिमेंट लिखे इसमें वो 2 बार जीतेगा, फर्स्ट में B थी और लास्ट पे C है.
So what's your question? I think we lost you. I can't hear you. I'm sorry, I can't hear anything.
Sorry.
I'm sorry, I can't hear you, so I'm just going to continue. We had this question, ABCD. You have 4 objects ABCD, you fix A at the first position, and then you have to pick a total of 3, but the first position is fixed. So in how many ways can you fill the first position? Anyone? In how many ways can you fill the first position? Anyone?
3 factorial multiplied by 2 factorial.
A is fixed, there is only one.
There's only one way because A is fixed. In how many ways can you fill the second position? How many letters do you have?
3 factorial.
2 ways.
2 ways.
See, sometimes we overcomplicate the question. There's only one position. How many letters do I have with which I can fill?
3.
3. Because A is taken. So this can be filled with any of these 3. And the last position can be filled in how many ways?
2.
And that's your answer, 6. As long as, see, if you're confused by these formulas, permutation, combination, what do they mean, when do I use them? Look, as long as you're using common sense, a little bit of thought, थोड़ी सी effort, a little bit of effort, and the multiplication principle. you will solve most of these questions, almost all.
सर ये जो 6 आंसर आया ये रेपिटेशन रख के आया कि रेपिटेशन निकाल के आया?
Can there be repetition? Are my objects distinct? Right? There cannot be any repetition because I had 4 different objects. One was called A, the other was called B, the other was called C, the other was called D. And once I picked A, if A came here, then A is gone in the remaining set. So it's like picking from a basket where you have A, B, C, D, 4 objects. You reach in and pick an object. Well, to answer your question, yes, we pick an object and we put it aside. We remove it from the basket. So now only 3 remain. This is called picking without replacement. Right? Now you could have done picking with replacement. So you pick an object, note that it was A, but then put it back. Right? This is called picking with replacement. We haven't covered this. Okay. We're dealing with this. We're dealing with this. Okay. Let's do some examples.
सर ए हमने फिक्स कर लिया तो अगले में तो तीनों में से कोई भी आ सकता है ना?
Yes, absolutely.
तो उसके साथ फिर फैक्टोरियल नहीं लगेगा मींस?
Okay, great. So this task is completed in 3 stages. In the first stage, we pick. There's only one way of completing the first stage. You just pick A. But once you have picked A, now you have 3 options. For the second object, you could pick B, you could pick C, you could pick D. Am I right?
Yes.
So this is what I meant when I said sometimes we overcomplicate the question. When we're dealing with the second stage, it means I only have to pick one object. So I just look at my options. I have 3 options. Okay, I make these 3 branches. And then the third stage, I have to pick one more object. But how many options do I have? 2. Right? Because I've already picked A and then I picked some other object. Now only 2 remain. So from those 2, I pick one more. So the total number of branches that I get are 6, which is 1 into 3 into 2. Zaim, did you ask the question?
Yes, sir.
Is it any clearer or not?
Yes, sir.
Okay. And Zaim,
sir, explain one more time.
You ask me a question. What's the confusion?
Sir, ye branches.
If you don't understand the branches, you have to look at the previous lecture. The previous lecture explained the multiplication principle. So I would advise you to have a look at the previous lecture as well. Okay.
So what's the remaining two thing? Could you explain it, please?
This one?
Yeah. In the question, it's written like remaining two. What does that mean?
Yeah. Okay. I'm sorry. So the complete question was, because we had continued from these previous questions, so I didn't write the whole question. The complete question was, you have 4 distinct objects, all right? You have to pick 3. Okay, you have to pick only 3 from these 4 objects. But the condition was you fix A at the first position, which means you can't really pick the first object. The first object is already fixed at A. A is going to be at the first position. So really the question was only, if you think about it, the question was only, so the question said, how many ways can you pick the remaining 2? Okay, so really the question was from 3 objects, because A was chosen, so the 3 objects are B, C, and D. In how many ways can you pick 2? Really, this was the question. And for that, the answer is P3, 2, which you can check is 3 factorial over what's the answer? N minus K. Yeah, 3 factorial over 1 factorial, which is 6. I mean, if you wanted to use the shortcut, you could just do it this way.
Got it, sir. Thank you.
No problem. But I did it using the multiplication rule. So that whenever you guys are confused, oh, well, order matters, order doesn't matter. When order matters, do I pick permutation or do I pick combination? Whenever there is any of this confusion, just fall back to common sense and the multiplication principle. Okay? Because all these rules are derived from the multiplication principle. Okay. Okay.
सर अगर हमारे पास क्वेश्चन है कि how many words can be formed from the word Pakistan if we place P at first position, then उसका क्या होगा?
Okay, if we go fast enough, we will cover. Actually, you have a very similar question, as in your practice set. The second practice set that I will upload today, you will have a very similar question. So let me continue. If towards the end of the class, if we have time, I will come to your question. Okay, at the end of the class, remind me of your question.
Okay. Sir, practice set के answers भी मिल जाएंगे?
Will you get answers for the practice set questions? Is that what you're asking?
Yes, sir.
Of course you will get the answers because you will compute those answers.
No, I am asking by your side, sir.
Well,
answer key.
You've gotten my answer, right?
Okay, sir.
Great. So, well, that's what the office hours are for. That's what my email is for. I mean, the idea is you should attempt those questions, attempt them honestly, take help from each other, and if there are genuine concerns, if there are genuine problems, discuss with me. Send me an email. Okay. Okay. So let's look at a question. Suppose that you have 3 apples and 4 oranges in a basket. And suppose that the fruits are all mixed up. You put your hand in the basket and draw three items. Without looking, without choosing, without picking, without selecting any kinds of items yourself. You just blindly pick three items from the basket. So that's your experiment. You have a basket containing 3 apples and 4 oranges, and the fruits are all mixed up. You reach in the basket and just randomly pick 3 items and take them out and note which items you have. That's your experiment. In fact, for this question or for this experiment, the first thing that you do in any question related to probability is you decide what your sample space looks like. What will be a typical outcome of this experiment? So when this experiment is complete, you will have an outcome. For example, you will have the first item, the second item, and the third item. Now this could be apple, orange, orange, or it could be some other triplet of fruits. Orange, 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 or maybe apple, apple, apple. So the point is that all the outcomes, all possible outcomes of this experiment, which you call the sample space, all possible outcomes of this experiment will be in the form of these triples. You'll have many of these triples. So that's what your sample space is going to look like. So that's the first step. The second step is you ask yourself, is your sample space a simple sample space? Which means is each outcome, is each triple equally likely? Since the fruits were all mixed up in the basket, there should be an equal chance of obtaining any triple of 3 items. If the fruits are all randomly, if they're mixed up in the basket, then the chances of obtaining 3 oranges should be equal to the chances of obtaining 1 orange and 2 apples, which should be equal to the chances of obtaining 3 apples, because they're all mixed up. So any triple has an equal chance of occurring. So yes, the sample space is simple because all the items are mixed up. There is no preference for a certain set of 3 items to have more chance of being picked up. All have equal chances. So that's the second step. Okay. Now let me ask you some questions. First question is this. In fact, the first question is, what is the size of the sample space? What is the size of the sample space. How many such triples can you have? This question can be reformulated in this way. In how many ways can you draw or pick or select three items from how many items do we have? 3 apples and 4 oranges, so that's 7. 3 plus 4 equals 7 items. Right? This should be equal to the size of the sample space. In order to answer this question, first you have to decide if order matters or not. Does ordering of items matter, or does it count or not? To answer this question, let's imagine that we have our basket. We have our 3 apples and we have our 4 oranges, and we draw 3 of these items. Now, once we have the 3 items in our hand, then it doesn't really matter. For example, let's say we had apple, orange and orange. Because I've just picked them all at once, it doesn't matter. I'll still call it, oh, I got 1 apple, 2 oranges. Their arrangement doesn't matter. If I can arrange them like this, or if I can arrange them like this, or if I arrange them like this, whichever way I arrange them, I still got 2 oranges and 1 apple, and that's what counts. So their ordering should not matter for me. And when ordering does not matter, then the number of ways that you can pick 3 items from 7 items is given by the combinations formula, which is just the permutations formula, in which ordering does matter, and you divide the number of orderings, or you divide the number of permutations by the number of orderings of each set, because we don't want to count the individual orderings. And this gives you 7 factorial over 7 minus 3 factorial. This was the permutations formula, and you divide by 3 factorial. That gives you the combinations formula, and the answer would be 7, 5, 6, 4 factorial over 4 factorial, 3 factorial. 4 factorial cancels out. 3 factorial is 6. 3 factorial and 6 cancel out, and you get 35 different ways. Okay, so this should be the size of your sample space. This means that from the 7 fruits, if you randomly pick sets of 3 fruits, you can do this in 35 different ways. Let's see if we can enumerate this. Now 35 is a big number, so let's try and find these sets. Maybe we get tired and we give up, but let's start. If I have a basket of 7 fruits, okay, so I have apple number 1, apple number 2, apple number 3, orange number 1, orange number 2, orange number 3, orange number 4. And I want to pick 3 items. Okay. Now let's say I pick instead of enumerating all options, let's say the first item that I have, I'm going to pick 3, but the first one that I have, that can be selected from 7 options. So I have 7 options over here. But if one of them is gone, then the second option, the second item can be selected from 6 remaining fruits. And if these 2 are gone, then the third item can be selected from 5 remaining fruits. By the multiplication principle, this is the number of ways that I can select 3 items. But remember, the multiplication principle considers A1, A2, and O4, for example, and A2, A1, and O4 as different permutations, right? Whereas for us, it's the same combination. It's just the same 3 items, but arranged differently. But if I don't want to count the different orderings of these 3 items, then I can just divide by the number of orderings that 3 items can have, because this multiplication formula has counted all possible orderings. So for any 3 items, let's say these are the 3 items, A1, A2, and O4, just as an example. These 3 items can be arranged in 6 ways. Why? Because you can have 3 options for the first position, you can have 2 options for the second position, and only 1 option for the last position, and you multiply them and you get 6, right? So 3 factorial, right? And so all I need to do here is divide the number of permutations by 3 factorial, which is 6, and I get 35, right? Which is exactly what happened with the combinations formula on the left, right? So that's just a way of elaborating on how you can compute the size of the sample spaces. Now let me ask you another question. In how many ways can you select or draw or pick 2 apples and 1 orange. Two apples and 1 orange. So we say let's call this our event E. Our event E is the set of 2 apples and 1 orange. Okay. Now let's first try and enumerate all the possibilities so that we can verify. Once we use a formula, we can verify if the answer was correct. So we had 7 fruits, A1, A2, A3, O1, O2, O3, O4, 4 oranges. Now, if I was forced to pick 2 apples and 1 orange, I could have done it by selecting apple 1, apple 2, and orange 1. Or I could have kept these the same and selected orange 2, orange 3, orange 4. Okay. Or I could have selected A1, apple 1, and apple 3. And then I would have had the same 4 options for orange 1, orange 2, orange 3, orange 4. Okay. Or I could have selected apple 2 and apple 3. And for this configuration of apples, for this pair of apples, I could have had 4 options: orange 1, orange 2, orange 3, orange 4. And since I can't have any other pairs of apples, A1 and A2 done, A1, A3 done, A2, A3 done, no other pairs can exist. Right? So this gives me 12 ways of picking 2 apples and 1 orange. Now let's look at another way of solving this. If I am forced to pick 2 apples and 1 orange, I can view this process as something to be done in stages, 2 stages. Stage 1, pick 2 apples. Okay. Stage 2, pick 1 orange. Okay. If I have to pick 2 apples, I have a total of 3 apples. I have to pick 2 out of them, and their arrangement does not matter to me. I just need 2 apples. From 3 apples, how many combinations of 2 apples can I pick? That's C32. And that comes out to be 3 factorial over 1 factorial into 2 factorial, which is 3. Okay. That's stage 1. Stage 1 can be completed in this many ways, 3 ways. Stage 2, you have to pick 1 orange from 4. How many different ways? C41, which is 4 factorial over 3 factorial over 1 factorial, which comes out to be 4. And since this task is completed in stages, total number of ways, which means the size of the set E, the size of your event, the number of ways that you could have picked 2 apples and 1 oranges should be equal to the number of ways that you could complete stage 1 multiplied by the number of ways that you could have completed stage 2, which gives you 3 multiplied by 4, which is equal to 12. And so the answers match. When we enumerated all the possible options, and when we found, or when we used the multiplication principle to find the size of set E, both answers came to be the same. Right? And you can kind of see the multiplication principle in the method on the right as well. Look at how many combinations you had. You had one combination, A1, A2 of 2 apples, and you had another combination, A1, A3 of the apples, and you had a third combination, A2, A3 of 2 apples. Combination 1, combination 2, combination 3. For each combination, for each pair of apples, you had 4 ways of selecting an orange. You had 4 oranges, you needed to pick one, you could have picked any one of them. So there are 4 ways. For each of these 3 combinations of apples, you had 4 ways of picking the orange. So this gives you 3 multiplied by 4, which is equal to 12 ways of picking 2 apples and 1 orange. And this multiplication principle that we did over here does exactly that. It does 3 ways of picking 2 apples multiplied by 4 ways of picking oranges. Okay, great. And once we have the size of the sample space and we have the size of the event, now I can ask you questions like this. What is the probability of picking 2 apples and 1 orange, right? Which is the same as asking what is the probability of event E, right? And so the probability of event E should be equal to the size of event E divided by the size of the sample space. Why can we, and the size is computed by counting in parts 1 and 2. Why did we use counting? Because the sample space was simple. When the sample space is simple, we can use counting to find sizes. And we have the sizes. The size of E was 12 and the size of the sample space was 35. And that's your answer.